I chose this master because it unites physics and environmental science. I think that completes the knowledge of someone that has a particular interest for environment, because you're able to apply your capability in governing equations to something that is useful in real life to tackle environmental problems. My thesis was about detecting nitrogen fertilized areas using Sentinel-2 imagery and artificial intelligence. This topic is really important because nitrogen fertilizers can have a harmful impact on environment, climate and human health. So developing an early warning system able to tell local authorities if there is a violation in nitrogen fertilizer regulation is important to prevent these harmful impacts. I greatly suggest this master to other students because of its completeness. Someone that studied physics or mathematics should also be aware of the biosphere, which is something that usually is not studied in this kind of degrees.
I chose this master degree in science of climate because I had a mathematical and scientific background, and I really wanted to apply this knowledge that I got into something I believe on, because I really believe that we have to do something for the current climate crisis that we're facing. And my aim was studying and trying to understand the physical and biological mechanisms in order to do something for future knowledge, and because I really care of what we're talking about. My thesis was on marine productivity in the eastern boundary upwelling systems under climate change. I studied marine productivity, so I investigated the role of phytoplankton, which are important for the ocean global carbon cycle, and then also in the marine food web. And particularly, I investigated marine productivity in the eastern boundary upwelling systems, and I evaluated how this primary production will change because of anthropogenic impact. And in particularly, I focused on different scenarios of climate change.
I chose this master because I had a background in physics. So I was very interested in atmospheric phenomena and also kind of interest in climate change. So this was the perfect choice to keep going with my interest in physics, but looking at the atmosphere and climate science. My thesis is about the representation of tropical cyclones in the CMCC seasonal forecast model. So we study model evaluation, so looking at climatology, internal variability, and the spatial distribution of tropical cyclones in the model compared to the real world, and then we look at the representation of the favorable condition for tropical cyclone genesis. I think that this master provides a very complete overview of the climate system. So first of all, we have a very strong background provided by this master on the atmospheric and the oceanic circulation, but we also have an important look at the paleoclimatology and the hydrogeological risk, which is also very important due to the impact of climate change on society and on land.
my bachelor degree in astronomy. I really didn't know exactly what to do because I loved physics, but also I wanted to have a more input on what's happening today, and I feel like this particular master's degree really is able to combine these two things. So we have the physics part, which is the physics, the dynamics of the atmosphere, oceanography, which are really important and something that I really liked, but also a view on what's happening today and what will happen in the future. So climate change, how is impacting also biodiversity, so we have some insight on biology and geology as well. My thesis was about landscape classification of forested areas and biodiversity assessment with the spectral variation hypothesis. I would suggest it absolutely, especially because it allows you to have a view not only in the physical side of it, which is obviously really important, but also to touch many other subjects, so geology, oceanography, also biology, which is fundamental to fully understand the problem of climate change.
I chose the Master of Science of Climate because my great interest in the climate changes and the future of my generation. Because we know that the climate system, the climate crisis is a complex threat that encompasses all the, threaten all the ecosystems and the services on which modern society depends. Climate crisis, the public awareness of what now is referred to as the climate crisis is a very long and ongoing process that is influenced by political and economic interests. In my thesis, I focused on the political and economic aspects of the climate change. The advantage of this master is the fact that it is interdisciplinary. So we can focus on the scientific part of the climate change, but also the economic and political interest of the climate change.
I come from a background in physics. Then, at the end of my bachelor, I found out that this is a very interesting field from a whole lot of point of views. So basically, we can deal with the climate system in some quantitative ways, very like maths and physics and stuff like that. We can deal it from an observational point of view, and that is what I was most looking forward to it. So basically opening my horizons, coming from physics, but still having something that is very grounded in quantitative sciences. My thesis was about the climate forecasting, the seasonal climate forecasting, so basically the forecasts that are from around 1 month to 7 months of sea surface temperature and surface air temperature using some machine learning models, so basically dealing with artificial intelligence method and stuff like that.
Climate change is one of the most important things that we should care about, especially at a political level. It's an interdisciplinary course of study, and we had the opportunity to study both physics of climate and, for example, ecology, and also one course in machine learning that should be one of the most important fields in the future. My thesis was about finding relationships between groundwater storage trends and internal migration and conflicts separately. In doing so, I used model data for groundwater and the observation for internal migration and for conflicts. The results that I found was that there is a slight correlation between the negative anomalies for groundwater on one hand and the increase in the number of conflicts and increase in internal migration on the other end.
Actually, at the end of my bachelor, I wanted to study ocean, but in Italy it is not present a degree that permits you to study ocean. Science of Climate was starting that year, and it was a very good union of ocean properties, of atmospheric properties and so on. So what I have done is study this degree, since it is a very good way to study the ocean. My thesis talks about a way to improve data assimilation, which is the union between models and observations, in particular in the ocean. And it is a way in which we can extract profiles of temperature and salinity from sea level. And this is a good way to improve data assimilation, since sea level data are assimilated through temperature and salinity profiles, so it is important to include them. I think that this master is a very good choice if you want to study the physics that is behind the climate changes and behind the climate itself, not only climate changing, but in general the climate. And I very suggest to take this course, since I think that professors and colleagues and also the topics that you are going to analyze are very important nowadays, and they are very, very interesting.